Welcome to Linacs Actuator Academy video series for industrial actuators. I'm Hunter, and today we're going to talk a little bit about brushless DC motors, their functionality, and how this motor type affects the performance of an electric linear actuator. We're also going to take a quick look at how brushless DC motors differ from DC motors with brushes. An electric linear actuator is made up of three main components: the gears, the spindle, and the motor. These are typically connected like this. A brushless DC motor, commonly called a BLDC motor, is driven by direct current, or DC electricity, and uses the electronically controlled commutation system. This is an example of a brushless motor. Like all motors, a brushless motor has a stator and a rotor as its major parts. The rotor is made of permanent magnets, and the outer part, the stator, has several copper windings depending on the number of magnetic poles on the rotor. These windings are placed in slots which are axially cut along the inner periphery of the stator. The motor is running when the rotor is spinning inside of the stator. Electronics make the rotor spin by inducing a series of magnetic fields in the copper windings that can push and pull the permanent magnets in a sequence that ensures continuous rotation. These magnetic fields can be controlled with different commutation methods. In our example, they are controlled by the so-called trapezoidal wave control using our built-in Hall effect sensors. The Hall effect sensors are able to estimate the current position of the magnets and thereby decide which windings to run power to in order to create the magnetic fields that push and pull the magnets into the desired direction. A simple brushless motor has three Hall sensors that are embedded into the motor. Whenever the rotor's magnetic poles are near the sensors, they will generate either a low or high signal depending on the pole polarity. The exact commutation sequence to the stator's windings is then calculated based on the combination of these three sensors' feedback. Let's dive one step closer into what this process looks like. When a rotor magnet approaches the magnetic field that's pulling it, one of the Hall sensors, depending on the rotor position, will be activated and change its output. This change will signal the electronics to energize the next winding and create the new magnetic field necessary to push or pull the rotor forward in the desired direction. The rotor can then be made to spin the other way by simply flipping the current to flow in the opposite direction. The efficiency of a brushless motor is the relationship between power input and power output, measured in watts. The brushless motor is a highly efficient motor type with low energy loss from input to output. Because the Hall effect sensors always know the position of the rotor, they can be used to regulate speed. For example, you can make the motor keep a constant speed even when increasing the load on the motor. In the context of actuators, this means that you can obtain a constant speed even with increased load on the actuator because the electronics can allow greater voltage to the windings, creating a stronger magnetic force on the rotor. The motor's ability to stop and hold a certain amount of load can be affected by the cogging torque of the motor. The cogging torque of electrical motors is the torque due to the interaction between the permanent magnets of the rotor and the stator slots of a permanent magnet. The higher the cogging torque, the higher a load the motor can stop and hold. However, increasing the cogging torque also introduces torque ripple and can reduce the efficiency of the motor. Because a brushless motor is controlled by electronic commutation, there will be no physical contact in the motor. This means that there is hardly any mechanical wear on the components, and as a result, the lifetime of this motor type is often very long. Because of this, if you have the need for an actuator with a long service life, it's highly beneficial to consider one with a brushless motor. Let's run through some of the main differences between DC motors with and without brushes. Unlike the brushless motor, in a motor with brushes, there's a constant physical contact between the brushes and the commutator that make the motor run. This constant friction wears down the brushes until they can no longer make contact with the commutator. This is the primary reason for the significantly shorter service life of a motor with brushes. That friction also causes noise, which results in brush motors being often noisier than their brushless counterparts. Another factor that can limit the noise is the way you control the motor. The more efficient the control, the less noisy the motor. The brushless motor is generally more efficient than a motor with brushes because the brushless motor has less mechanical efficiency loss. Another important difference between the two motor types is that the brushless motor creates no sparks, which makes it suitable for use in a range of environments that a brush motor wouldn't be. A brushless motor also creates less heat than a motor with brushes due to the efficiency gained by lower energy losses from factors like friction and noise, along with the absence of sparks. Because of this, less material is needed to absorb the heat and cool down the motor, allowing the brushless motor to have a smaller profile. When it comes to cables, the brushless motor is more complex than a motor with brushes. Instead of just 2 motor leads, you have 3 motor wires and 5 feedback wires for Hall sensors, which require specialized controls to manage. Because of this, it's relevant to point out that this motor type is a bit more complicated, as it requires more electronics to control the motor than a brushed one does. For optimal efficiency, it's important to use the best control method available for your application. If you purchase a product with a brushless motor, for example an actuator, the question of controlling the motor is, of course, already taken care of by the manufacturer. We hope you enjoyed the introduction to brushless DC motors, their functionality, and how brushless motors differ from the motor with brushes. If you have any questions about brushless motors or electric linear actuators, feel free to contact your local Linac office. Thanks for watching.